All right, this is Unit 2, Section 2.4 on histograms. So this is going to be our third method to displaying quantitative data. And so our goal today is to be able to look and start calculating measures for quantitative data, and that's really as we start to describe it numerically. So we're mainly going to be focusing on this last way of starting to describe our data visually, and then we'll start calculating the measures of center, position, and those things as we move into describing it numerically as well. So for a histogram, this is similar to a bar graph where the values of one quantitative variable are maybe so numerous that they've been grouped into classes of the same size or width. Each bar is going to represent the frequency of counts within a class or range of values, not just one variable or one value. What's different about histograms compared to our dot plot and stem plot is our histogram and then our last one, our box plot, don't show the individuals. They show groupings or ideas about the distribution, but they don't necessarily create it to be one individual. So as we take data from a dot plot and then arrange it so that we have, okay, between 0 and 5 we have this many, between 5 and 10 we have this many, and we're just counting them up so that we don't see the individual values, that it's not 2, 3, 4, and 5, and then 6, 7, 8, 9, 10. Now it's just this many between 0 and 5, and that's where we can start to make our histogram. But once we do that on our histogram, we can no longer see an individual. So we want to keep that in mind, that a histogram is a great way to describe large data sets where we want to talk overall the group and not individuals anymore. So the way that we build a histogram is looking at our data here. It says each of the 50 of the United States reported the percent of their residents who were not born in the United States. Make a histogram of this data shown below. So what we're going to be looking for here is a way that we can start to group all 50 data points in such a way that it's not us making a dot of every single one of these, or a stem plot where this would be hard since there are decimals and have quite a bit of a range here. So what is the range of the data? What is our max minus our min? So this is where we'll start talking about describing our data numerically. The maximum, if we look through our list of data, I believe is this California, 27.2, minus our minimum, and that as we look through, I believe is West Virginia here at 1.2. So our range is this 2.6. So, oh, good grief. Let's say 26 here. Put a decimal in there. 1.2. Subtract. I don't know why I had a decimal in there. Anyway, the range is 26%. So we have one state in California where 27.2 of their residents are not born in the United States. And then we have West Virginia, less diverse, where only 1.2% of the residents were not born in the United States. Kansas, only 6.3 of the residents were reported to not be born in the United States. All of these numbers, we don't know what date this was. When was this data recorded? So even though they give us the data, we have some questions about when it was collected, because maybe it's changed, better or worse, as far as increase, decrease, whatever that would be. The second part, I guess the first part is knowing how big of a data set do we have. We have a range of 26 percentage points. The second one is to select a class width and define the classes. So when we range by 26%, I think I'm going to pick 5. Sometimes it's, with 10, I would only have 3 different classes. So I think with 5, I would get 5, almost 6 classes, and I think that would spread my data out a little bit more. So my class is going to be 5%, and so I'm going to describe it as 0 to less than 5%, and then 5 to less than 10%, and so on until I would get to 27.2. And so when we start making this frequency table, we'd look at our class. So this would be 0 to less than 5. This would be 5 to less than 10, and so on. And our last one. So I have 1, 2, 3, 4, 5, 6 different classes here. And then I'm going to go through and count how many fall 0 but less than 5, 5 to less than 10, and just put a count here. Okay, so if you wanted to pause and fill in the count, you can, or I've gone ahead and counted it where we have 20 here, 13 here, 9, 5, 2, and then only 1, only California is in that range of 25 to less than 30. Once we have a count here, we can create our histogram. Make sure that we are labeling things, just like it is an easy way to lose points for forgetting the key on a stem plot. It is easy to lose points on a histogram without labeling the axes. So this is going to be the number of states, or the count, or the frequency of states. And then our bottom part is going to be the percent of non-born in US. So we're going 0 to 5%, 5 to 10%, 15, and then we have 20, 25, and 30. And then what we're going to label here, we need to decide as far as numbers from 1 to 20 what our scale would be. And so maybe 5 would be a good measure here as well, giving us our max at 20. And then I can draw this in as my histogram. And again, that's a little wiggly, but these now, the difference from a bar graph to a histogram, these are going to connect because where this group leaves off, this one will pick up at that 13. And again, I'm missing a little bit, sorry. Ooh, takes a second to get better at this. Maybe I should come from the bottom. Ooh, still can't get it. All right, 9, 2, forgot 5. 5, 2, and 1. All right, so as we're looking at this, we have our histogram that now describes all of the, sorry, that was bothering me. So this has all of the data described, but we don't know what the individuals are inside of this. So I know there are 20 states that have a percent of not born in the U.S. of their residents, but this is, I don't know what 20 they are. I can't say, oh, there's one that's 0, there's one that's 5, maybe all 20 are at 2.5, but I can't see the individuals anymore where I could on a dot plot and a stem plot. So that's one of the drawbacks to a histogram. However, this is a nice distribution where I can say this is skewed right, this is, unimodal here. I could start describing it as not having any outliers. It has a variation from 0 to 30, and it starts letting me talk about the overall group of states without talking about the individuals. And so what we want to look at is creating a histogram is for large data sets or for data sets that have quite a bit of variation there. I wouldn't have wanted to make a dot plot and gone 1, 2, 3, 4, blah, 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 all the way to 30. That would just make a line here that was far too long. At the same time, I also don't want to plot 50 points on a dot plot or create a stem that would accommodate 50 states on a stem plot. This will be faster. And so as we start comparing those, a bar graph here to a histogram here, they do have some similarities that we would put in the middle here, but they also have some difference that are unique to each one. So a bar graph and a histogram do have bars in common. They're both created quickly with bars. It also uses heights to show the amounts. So a height on this one represents amount in that. So does it here. So this 4 still represents this. This 10 represents here. Then when we look at their differences, we can say this is going to be for categorical data, because even though they are in, I think this is alphabetical order here again, we still can't change, we could change the order on this. We could make it biggest to smallest, smallest to biggest. We could pick opposite of alphabetical or random. But we could rearrange these bars. Where on this one, because the data is quantitative, now we would have this data that would be represented, and we couldn't rearrange the numeric values down here because there's an order that we've all accepted as left to right, we're getting from smaller to bigger. So I wouldn't want to take this column and say, oh, 0 to 2.5, you're going over here now. It wouldn't make sense. But if I said, oh, I want this one because it's the smallest to go over here, why not? We could do this. We're not going to do that. That's a difference here. This is going to be a discrete number of choices. So this would be, you fall into one category as far as you're here, 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 or here. And then this would be continuous, where the categories start from one and pick up on the other. So these two are discrete. There's nothing related to them. If I pick up here, it doesn't mean that I fall into this one. Here, they're continuous, meaning if I don't fall into this one, I might fall into this one. And if I don't, I fall into this one. So that's a continuous idea, not discrete, which means it's kind of broken up here, where it jumps from one to another. And then this one, the more obvious one, is the spaces between it, and this one has no spaces. There are more similarities and differences that maybe you see, and so if you want to add to this, you can. The last part that I want us to be able to do is, because making a histogram is our first distribution that's not as quick to do by hand, this is where we can use our graphing calculator to make a histogram for us. So what we're going to do is put all our data into list 1, and then we're going to start to organize this data so that it looks like the one we've created. And so I will show you how to create that, but this is a note that helps you remember if you forget. Do this with me on your calculator. Watching me do it seems great, but pause, enter your data, pause, make sure that we match up. And if not, let me know, because sometimes if you have like a rented calculator or you're borrowing from your siblings, they might have done something in their graph where it might not display the same as mine, and we want to make sure that we get the same thing here. All right, so on my calculator, I'm going to look at, going back to my home screen, and the first thing I'm going to do is go to Stat and then edit my list. So what I'm going to do is, looking at that list of all 50 states, I'm going to enter that in. So I have 2.8, 7, 15.1, 3.8, and all the way up. And this is the tedious part, which is why in AP Stats, we typically work with small data sets. But as you get into computer programming or Excel sheets or slide, or what do they call it, sheets in Google, you can start working with large data sets and manipulate them as well. Typically, because we are limited on time and our technology available to us, we use smaller data sets. And even 50, 100 would be considered small. So hopefully I haven't made any typos here as we get all the way to 50. And so I've entered in all my data. So that's going to be my first set. And so what it asks us to do then is go to second y equals to get to the stat plot. So I'm going to go to second y equals, and my stat plot here, I want it in position on, which darkens this one here. So if I turned it off, it would, now we're actually looking at stat plot 1. So I want it either on or off, and this one we want on. The type that I have here is a scatter plot, a line plot, a histogram, then we have box and whiskers here, and a normality plot. So right now we want to look at the histogram. So when I select this, it'll darken. And the list that I have mine in, when we did stat and edit, I was in list 1 here. So that's what I also want to report when I'm in second y equals. I want it to be list 1, frequency 1, meaning each of my observations happen once. And then once I have that, I have highlighted on, I arrow to the type, I'm choosing my histogram, and then I'm going to hit enter. Make sure it has X list chosen as list 1 or wherever your data is. And then we can do second mode to quit, or we can go right to our data plot by zoom 9. So this zoom is going to be our favorite zoom for stat because it's going to square up our window based on the data that we've entered here. So when we look at this, I can either go second quit, and then I can go zoom 9, or straight from the y equals. From here, if I have everything entered in, I'm ready to zoom 9. And so as I look at this data, it doesn't quite look like ours because right now there's a gap here. And so if I trace this, hit trace here, it says there was 20 here. Okay, that's what we had in our first group. But then there was 11 here and we had 13. And so some of this is jumping around. And if you look at it, they've created this by trying to make it fit perfectly into the window. They've created this calculator version of the classes saying it's 16.057143 to a maximum less than 19.771429. We did not choose those. The calculator did. If we wanted it to look like the one that we created, or if on a test we were asked to create one with a certain class size, we could go to Window, and notice they said start at 1.2. Well, let's start at 0. The maximum we have, sure, we can do 30 because our graph went up to 30. And then this is where we can change the scale. And so the scale here, this is what they're telling us to count by. So we said we wanted to count by 5% for our class width. The X's class width here is 3.714. This isn't something that we typically would have chosen. So let's make it 5, like we had chosen originally. And then minimum for 6, maybe we're going to keep it -1 just so it shows it. Y maximum, we went up to 20, so maybe 20 is good there. And then the Y scalar, we can count by 5s or by 1s, but I would keep that again as an integer, not a decimal. And now when I go back to graph, this will look like the one that we had before. And if I traced it, we have our 20 again, 0 to 5, 5 to 10 was 13, 10 to 15 was 9, 15 to 20 was 5, 2, and 1. And this would match the exact same one that we created by hand. This is one way that we can change the scale. So if I said, let's change it to 10, okay? I have to keep in mind, let's change this to 10, and I wanted this at -1 still. By changing the scale here, I'm condensing our data, so I'm going to need to make this taller, but I don't know how tall because I haven't made this one by hand. So now when I graph it, now do you see that because I went by 10, 0 to 30, I have 3 groups. We're tracing it. Now I have from 0 to 10, there's 33. From 0 to 20, there's 14. And 20 to 30, there's 3. Collapsing those together. And again, I wouldn't want to go, oh, let's make this 20. Because then as I graph this, we're going to get ones that are way too big where it's like, okay, this isn't giving us a good distribution when we trace it, saying 47 of our data points fall 0 to 20, and only 3 fall outside of it, it just doesn't display as nicely. So even if we're making it on our calculator, it's going to zoom 9 and kind of think how many classes it wants. And so this did 1, 2, 3, 4, 5, 6, 7 classes. And if we're just asked to sketch it, that's fine. We can do this quickly just by tracing and saying, okay, here's the scale, and kind of estimating these numbers for the scale on the bottom. I still like to go back to window and change the scale to something more reasonable so that at least the X's are nice numbers along there, integers instead of decimals. All right, if you have any questions or if your calculator's acting funny and you need help with it, let me know, and I hope you have a good day.